What if the next breakthrough in wind energy isn't building bigger and taller turbines, but designing the right size systems that communities actually embrace where power is needed most? Welcome to Industry Ignited, the podcast where we explore the leaders driving transformation across industry, manufacturing, and technology. I'm your host, Dr. Leeanne Aguilar, and today I'm joined by Frank Gagnon, founder and CEO of Windu Energy in Montreal, Quebec, Canada. Frank, welcome to the show.
Thank you very much for the invitation.
Yeah, I'm excited to learn all about what you're developing in wind technology. I know you've run several manufacturing companies of different sizes. What experiences from the manufacturing world most shape the way you approach energy technology today, especially around cost, reliability, and scalability?
Yes, that's a good question. I'm an industrial engineer. So my thinking is like an industrial engineer. I don't try to reinvent everything. I take a product and I think the way I can make it better. And in my approach, I try to put myself in the place of my customer and see what's their need and what can I give them that's going to enhance their business or their life or whatever they need. And sometimes I may come even with projects that they don't expect. So what I've designed as a wind turbine, nobody ever see it before. So it's something that could be extremely useful for a lot of people, but I'm going to have to make some education about it because people never had seen it in the past. So it's going to need to make some kind of demonstration about it.
Yeah. So you're approaching innovation and technology from an industrial engineering background and looking at the entire problem and, coming to solutions that way. So it's not necessarily what someone might expect, but it's looking at it, big picture.
They call that, I'm an engineer since many years now. They call that re-engineering. You start with the project and say, what's the good of it? What's the bad of it? And how can we improve it? How we can improve the good and reduce the bad? And this is what I try to do with wind energy since many years now.
Yeah. So was there a specific moment or problem you saw in the wind industry from the inside or as an observer that made you say there's a better model than bigger is always better?
There is the giant wind turbine is mature technology. We understand that. It's produce good quantity of energy. It's spread all around the world. And it's very helpful to produce more clean energy. But there's a lot of problem with it. They are not accepted everywhere. You cannot make wind turbine in a city, for example, even near a city or near a village. The electricity production is random, so you cannot depend only on the wind energy. There is noise and visual disturbance.
Right.
Having a profitable wind farm with giant wind turbine, you need to make a very large project. It's cost many $100 million. So sometimes it takes years to start the bid, to start the tender. Then you need to talk with people, and sometimes you work for a year on the project, which is can sell because people don't want to see it nearby in their background. And there is also some decommissioning problem. We know today that the large blade, they are synthetic product. They start to be able to make the reuse of it, to make recuperation. But there's a lot of them that have been directly garbage. So there's few problems around that. But it's clean energy, and we need clean energy. So if we can change something, make something better, there is a room for it.
Yeah. And how did your background as an industrial engineer shape your view of the energy sector and ultimately lead you to build a company focused on mid-scale networked wind turbines rather than traditional large-scale models?
Okay, I'm an industrial engineer again, so what I try to do is something that can be produced in large series. So with automation, large wind turbine, every wind turbine is almost a custom project. Today it's less than that. But it's a very big project. You have to do engineering every time you install a wind turbine. And it's big factory that are one-purpose factory. You have a factory that do blade, they don't need that. So it's not the way an industrial engineer thinks. So I want to make something that I can put the input in one side. I have some robots in the between, and on the other side, I have a project. It's not, of course, that simple as that. But that's the basic principle. It's not useful to try to replace a giant wind turbine. It's a good project. It's mature. but we can try to go where they cannot. So that's why I think to make it smaller, to reduce the noise and visual disturbance. And based on that, I start to make the first step is to make calculation. What's the good size? What's the good? You make approximative cost. What if I make 5 kilowatt, 10 kilowatt, 20 kilowatt, 50 kilowatt? And there is a kind of sweet spot. If you make it too small, the cost is too high per kilowatt. And if you try to get bigger, in between the giant wind turbine and the mid-scale wind turbine, there is also a gap, a place that it's not very profitable. So 20 kilowatt is very, very good. After many milestones, that's the best option. I decide to. Maybe some may decide other thing, but what I offer is based on 20 kilowatt.
Okay, so you really did the research and established like what that mid-range size would be as far as efficiency and cost. And
the quick installation, we need something that can be deployed fast. So the concept, okay, I don't try to sell one wind turbine here and there. I want to sell wind farms of many wind turbines. So you put a team on the field with a large contract of wind turbine. They come, they hammer the foundation, steel foundation. They can make 5 or 10 foundation per day with the good equipment. And then another team come to make the assembly of the wind turbine. They can assemble one wind turbine every day, 2 to 3 people, 4 people. So this is a different way to approach that.
Right, a whole nother model, right? Because I know right now the wind energy, it's pretty much dominated by the well-established players and large turbine economics. And you're more looking at that mid-scale operation, and you're saying that you're going to create the farms of the mid-size wind turbines. And so what convinced you that the mid-size network approach could succeed, not only from a technical standpoint, but as a commercially scalable and competitive business?
That's a very good question. There's many points for that. First, we want to offer something more reliable for the grid manager, for the electric operator. So if you have one giant wind farm of 100 megawatt, one day you're going to have 100 megawatt of electricity. And the day after, you're going to have nothing. Now, if you have, instead of one big farm of 100 megawatt, 1 megawatt farm spread everywhere, you're never going to have 100 megawatt total. You're never going to have zero. So it's going to be much easier for the grid manager to use that. Now, coming to a size of 1 megawatt, I can change the pattern. It's not anymore a giant corporation, international corporation, that's going to produce electricity. It's going to be farmer. They're going to install in their land, which is the best place for mid-scale wind turbine. They're going to install wind turbine on their land, and they're going to sell electricity to the grid, and they're going to enhance their business model. They're going to have stable product. Farmer, they don't have some stable product. One year they can do good money, the next year they make nothing. With fixed revenue or very, very stable revenue and energy, you make their life much more interesting. So it's interesting for everyone. And once again, I do not intend to replace giant wind turbine. We're going to go where they cannot. There's a lot of good windy place that they have refused giant wind turbine. We can come there and nobody's going to complain. We're going to put 1, 2, 3 at the beginning on the area to make people comfortable with it. And after, we're going to install 50 in one field or 75 in another field. And it won't bother anyone because it's the size of a tree. So at 300 meters, at 1,000 feet, you don't see it. Well, you see it, but it doesn't bother. But it doesn't bother. You don't hear it either.
Yeah. So you're basically making wind energy more accessible and putting it in places where the large wind turbines can't be placed currently. So for listeners who picture wind turbines as these massive structures, walk us through what Windu's turbines look like and large tree footprint concept and the core design philosophy. And let us show us what's fundamentally different. Explain to us.
You want to see an image of the wind turbine?
Sure. Yeah. I know you for those viewers watching on YouTube and by video, you can actually see. And then for those listeners who are joining us on a podcast, I guess talk us through the differences.
So for those who see the image, you have the wind turbine. It's an old concept. Darius wind concept is an old concept. It's necessary for mid-scale wind turbine. We can talk about that later on because it's very, very simple machine. Basically, there's one moving part. but I have few stair of arms with blade at the end, and they are offset one to the other. So the torque on the generator is very equal. The force on the structure is very equal too. But each blade is 10 feet high, 3 meter. You can see on the other picture, one of my partner beside one of the blade. This is standard blade. So every model use exactly the same blade. So this blade can be assembled in an automatic system. Now, in this second image, you see that we are going to produce 4 models of wind turbine. Okay, we have a model with 3 levels of blade, and we have a model with 4 levels, 6 levels, 8 levels. Wind is a soft energy. Okay, you need to catch a good quantity of wind to produce electricity, and the wind profile is not the same everywhere. There is an area that the profile is quite low. Produce the same 20 kilowatt, we need to catch more wind, because to have a wind turbine that is efficient, you need to produce at least a nominal capacity, 2,000 hours a year, at least for 35, 40, 45% of the capacity of the wind turbine. Sometimes it's need larger turbine, sometimes it's need lower. But it's always the same blade, it's always the same arms, it's always the same generator, always the same structure. Just only the size of the head change. So the largest one, you're going to have 20 kilowatt with wind of 13 kilometer per hour. While the larger one, the smaller one, you're going to need more wind. You're going to need maybe 25 miles per hour wind to produce. Except that when you have a large turbine, you have to stop it earlier. When there is too much wind, you can have structural problem, electronic problem. So you have to stop. That's why one model is better in one place, another model is better in another place.
Okay, just depending on the environment, the landscape, and
exactly.
Okay. Yeah.
In this picture, you can see how we install the wind turbine on the farmland. We gonna put that in ditch. So we don't use a square foot of cultivated land. This is very important. We enhance their business model, but we don't reduce their culture, their cropping. It's very important that they can produce, they don't stop their basic work. So it's become, and for us, it's the best place, because they are not too high. We don't want them to be too high. So we need a place that is relatively clean. So it's a good fit.
Yeah. Okay. So you'd work alongside farmers and place them strategically in areas, and so they're not interrupting the productivity of the fields. They're not taking up much space, and they're basically like large trees that you're putting inside of the irrigation canals. Is that right?
They have all this kind of small irrigation in their land. They have to, when there's a large rain, they need to be able to evacuate the water and everything. So they all have that.
Yeah.
And even if they don't, each wind turbine take about 10 square feet on the floor. So it's
minimal. Minimal. Yeah. Now, and you've also made a good point about lower noise and lower visual annoyance, plus improved safety for birds and bats. How do you engineer for community acceptance and environmental impact without sacrificing performance?
Okay, that's a good question. Birds, it's coming sometime on the discussion. A giant wind turbine, there's a lot of space in between the blade, and the blade run at 200-300 kilometers per hour, 150 miles per hour. Our blade gonna work a bit slower. It's still fast. It's still 100 kilometers per hour, 60 miles per hour, but it's 12 meters wide. So it's always on the vision of the bird. So they cannot miss it. When it's giant wind turbine, they can have the impression there is nothing, and suddenly the blade passed it. So there is possibility of impact, which is not as bad as people say, but that's another question. But this system, they're going to see it. And for the paratrooper or the eagle, the top of the blade are painted in red. So when you're going to come from the top, you're going to see the wind turbine miles and miles away. On the floor, on the ground, you won't see it. But if you come from the top, you're going to see it. So it costs nothing more to do, and it's more safe for the bird and for the people that you can have small plane. You can have, this can be installed not far from a small airport, and there would be no risk with it.
Yeah. And Windu also uses standard components and a modular design to enable automated manufacturing and assembly. Which cost drivers are you targeting most aggressively materials, installation, maintenance, or downtime?
Okay, I'm an industrial engineer again. I can calculate all the costing in the process. Okay, we're gonna have to start with a smaller factory because it's need capital, and before we can have money to have a larger factory, we're gonna need to make other. We're gonna go step by step. We don't try to run before we walk correctly. And in the production, every component of a wind turbine can be done by subcontracting. So I cannot have a bottleneck somewhere that, okay, I cannot produce this, I cannot produce this, because everything can be produced outside the factory. We're going to make this assembly. But if you want to be competitive on the international basis, you have to be integrated vertically. Okay, you take BYD in China, it's not only because they have cheaper labor than us. They have a factory the size of a city to produce the automotive, and they don't just assemble the part like they do here most of the automobile industry. They produce their own battery, they produce the raw material of their own battery, they produce their generator, that's same thing. So we're going to do a bit the same thing at our scale. We're going to and integrate in our production what's going to be the best cost efficient, because we're going to be at the beginning very competitive, but we have to stay competitive and we have to be more and more competitive.
Right.
So we're going to keep an eye on costs, and sometimes we're going to integrate that. Sometimes we're going to integrate that and make more inside product, so we don't have the multiplication of profit here and there that boosts the price for nothing. Step by step.
Yeah. You mentioned exclusive speed control on each turbine unit. What does that control system enable at the network level, and how does it improve efficiency versus competitors?
This is a bit a delicate question because it's concerned our IP. So I will not give you too much detail. Yes, wind turbine is a very simple machine. There is wind turbine that produce, there is corporation that produce wind turbine of 20 kilowatt, 45 kilowatt. I'll do like giant wind turbine, horizontal axis wind turbine, which is correct for the giant engine, but when you come smaller, it's too complicated. So it's very costly. So our wind turbine is very, very simple. We have one moving part. All the turbine, all the top is one part that turn and directly to the shaft, to the motor. As simple as that. But it's not simple. It's absolutely not simple to control that. A lot of people have tried to do various wind turbine. They all fail because they have not taken the time to analyze everything. They have not time to make computer simulation to optimize the blade. They have not time to watch at the speed, the relation between the speed of the wind turbine, the rotation, the speed of the wind, the speed of the generator. All this have to work together to be efficient. Mm-hmm. So that's the difference. But I won't tell you more.
That's okay, right? But no, it's interesting though, and yeah, I guess in just creating that. So it's the Darius concept, yeah. And can you tell me a little bit more about that concept though, and the history of it?
Darius concept is a vertical axis wind turbine that got a blade like horizontal axis wind turbine, like plane. Okay, and it's turned around the vertical axis. It's been patented by Mr. Darius 100 years ago.
Okay.
It's a very old concept, and it's worked. And a lot of people have tried things around it, and they all miss a lot of things. They have not done their homework before they do the stuff. They think it's simple. Aerodynamic is not intuitive. Mm-hmm. You cannot have an idea and it's going to work. It's not that simple. If you take the way, for example, Mr. Darius have described the patent 100 years ago, it doesn't work like that. Okay, it's work. The principle is correct, but mm-hmm. the way he described that, it's not working like that. If you make computer simulation, you see what happened around the blade at every space, and then you can make optimization. Then after that, you have to think, okay, how many blade, because if you I'm going to give you too much detail, but anyway, if you have, instead of 2 blade face to face, 3 blade is also good, but you see many wind turbine with 4 blade, 5 blade, 6 blade, altogether. The edge blade work on the turbulence of the previous one. So the efficiency dropped by 20-30%, just that, regardless of the thing. Sometimes you see a lot of structure about around the blade, the way they hold it. They don't take into account the drag of the arm system and everything. If you look at the arm is very, very thin. It needs to be that. And even then, I have to take into account the drag that it produces in the overall production.
Right.
There's a lot of detail like that need to be put together before you can say you have a final product tested, well, working. Some have tried in the past to put a prototype in a wind tunnel, and they say, oh, with this we produce this energy. In the field, doesn't work. Absolutely doesn't work, because what you see in a wind tunnel, you can see few things in a wind tunnel, but you don't see what's happened in the real world.
Right. Interesting.
And in the real world, if you put a wind tunnel, then you say you have 25 miles per hour wind. In real life, 25 miles per hour wind does not exist. It's always moving. So it's more or less, a bit. And you have to be able to manage it. If you let the turbine follow the wind, you're dead. It cannot. This is why we control the speed of the wind turbine.
Okay. Yeah. In the real world, there's not that consistency. It's not constantly 25, miles an hour. You're going to have those fluctuations. You're going to have variations.
Never.
Yeah. Got it. Now, Windu emphasizes wind farm networks optimized to local wind profiles and customer needs, including low wind regions. How do you model and configure a network, turbine types, quantities, placement to make a site economically viable?
Okay, there is two parts in that question. First, of course, when you install a wind farms for a customer, you have to understand his need, the purpose of the wind farm, how are we going to install it? What is the average wind of that area? What is the area beside the surrounding? What is the obstacle? What is the size of the land? What is the number of kilowatt or megawatt need? All this is basic work. But above that, because we are extremely scalable, we can offer a lot of different solutions that can improve, that can increase output for our customer, that can be more useful, more profitable for our customer. Maybe I have to show some image again.
Sure.
Okay. Now, on the top image, on the top graph, this is the standard production of a wind farm, of a wind turbine. You have wind, you have, let's say, the line on the top is 1 megawatt wind farm. Sometimes you deliver 1 megawatt, and the day after you deliver nothing. And on the average, you're going to, depending on a lot of factors, you're going to deliver 30 to 40% of the nominal connection you have to the grid. If you have 1 megawatt, sometimes you offer to the grid 1 megawatt, sometimes you offer zero. On average, over the year, you're going to offer the equivalent of 300 or 400 kilowatt. So this is the standard system. All wind farm actually work like that. It's correct, but it's for the grid, it's not easy to manage, because there's a lot of oil that you have to work with. Now, if we go on the bottom of the second graph, if you say, okay, this bottom line is 1 megawatt, but I install 4 megawatt of wind turbine, instead of for 1 megawatt, it's 50 of our wind turbine, I install 200. So I produce much, much more electricity. When the portion of the time I can offer 1 megawatt is now 60 to 80% of the grid connection. So we can offer something very, very consistent for the grid. The rest of the electricity you cannot put on the grid because it's not your connection, but you can use it. It's on site. It's there. So today, the batteries, for example, are much less expensive than 10 years ago. You can take a part of the electricity and fill the whole year and offer something much more consistent to the grid.
Yeah.
Or you can use this energy locally. If you're a farmer, you may heat up some building, may heat up greenhouse, you may produce hydrogen. There's a lot of things you can do. So there is a splitting. Of course, you're not forced to do that for one. Let's say that 1 megawatt is 50 wind turbine. You have a connection with the grid, a contract for 1 megawatt connection. But instead of installing 50 wind turbine, you install 60 wind turbine. You're going to offer more electricity to the grid, and at not at a much higher cost, because the loss going to be very small. It's not useful to try to use it for something else. You don't have enough. You offer more, you sell more to the grid. Of course, if your electricity basically costs you 4 cents per kilowatt hour, if you sell to 5 cents to the grid, well, if you drop your cost from 4 cents to 4.5 cents, it's no good. But if you sell electricity to the grid 8 cents and it costs you 4.4 cents instead of 4 cents, you deliver 10, 20, 30% more electricity.
Yeah.
It's more beneficial for your production. And the grid will not complain on that, of course. And if you go higher and higher, you say, okay, I offer you have a tender with the grid. You say, okay, the basic price is 4 cents per kilowatt. But if you want an efficiency of 60% instead of 30%, instead of give me 7 cents, you're going to give me 8 cents. The grid may decide, yes, I do that. You give them the choice. If they want more electricity, they're going to accept. So it's extremely flexible. And above that, a farmer can start with a basic system. The year after, they can add, let's say you have 50. The year after, they can add another 15 wind turbines. The year after, they can add another 10 wind turbines, or install a greenhouse and install another 25 wind turbines. So it's very flexible. So
a lot of flexibility.
Yeah. Based on that, we can build a lot of model for our customer. For example, here it's a farm. You have a wind farm installed in the land of the farmer that produce wind electricity. So always the same principle, random electricity. And the farmer, they pay the price of the electricity is expensive. So they use the most important part of the electricity produced by the wind farm for his own purpose. So it's more profitable, because if you sell electricity to the grid at 8 cents, but you pay 16 cents, well, you better reduce your 16 cents before you sell electricity to the grid.
Right.
Okay. Still, you can sell electricity to the grid, a good amount, that maybe pay everything, even if you don't do benefit. It make the rest free. It make the electricity here free. And you have some excess that are more difficult to manage. The excess of energy, random, you can produce heat with that very fast, high temperature heat. You can have a very efficient heat storage system that you can use for heat a building or heat a greenhouse or stuff like that.
Yeah.
When I start Windu, I was aware of that problem. I also create a system for the heat storage, probably to finance Windu. So it's useless to try to make two things at the same time.
You also talk about optimizing for different outcomes, max grid delivery, uniform on-site production, or even overcapacity to cover costs via grid sales. How do you help customers choose the right optimization target, and what trade-offs typically show up?
First, they don't really know what we can do for them. So we're going to have to explain everything. For example, the wind profile over a year is something, but the wind profile in summer and the wind profile in winter are different. You have most of the time twice the energy of the wind in winter. So if you want to have something equal all the year, you're going to go on the lower part of the wind energy on summer, and you're going to make your farm optimize to that level to reach your objective there. But if you want to heat up your building in winter, you're going to do the reverse. You're going to optimize your wind farm with the winter cycle. And in some case, if you want something very equal, more equal with low wind and high wind, you may decide to have a wind farm with some large wind turbine when there is low wind and some smaller wind turbine when there is high wind. So there is a lot of way to do optimization on each site, on each project. So that's why each project is different. And it's important to seize the objective of our customer. If they want to have the cheapest electricity cost possible to sell to the grid, we optimize the wind farm in that direction. But if you want to produce maximum electricity because he needs this electricity for himself, then the optimization is different. Especially if you got limited land, you can put more wind turbine in the limited land. It's going to be a bit less efficient, but we're going to achieve the energy he needs. On the reverse, we can have a larger. If you have a lot of land, you can make maybe more wind turbines, smaller, and have some other kind of flexibility. Yeah. But there's a lot of way to optimize a wind farm for our customer.
And like you said, it really depends on their objectives, on their specific land and their configuration of the property and their overall goals. So let's talk about the headline claim. Cost per megawatt can be lower than giant turbines in many cases. Where does the cost advantage come from most often? Manufacturing, logistics, permitting, community approval, maintenance, or something else?
That's a good question, because all those points are important. And the very first thing you have to remember is there's no two projects the same. So some going to have this advantage, some are going to have another advantage. Some going to have more wind, they produce cheaper electricity. Some, they're going to have cheaper capital. The first expense after you have installed your wind farm, the first expense is the loan you put on it, the mortgage you put on it. So if you pay a lower interest rate, you produce at better cost. There's a lot of variable that must be taken in account. So if someone comes say, okay, my wind turbine produce electricity at 4 cents per kilowatt hour, run away, because it's not working like that. I need to show you another. Okay. So you have the cost of the electricity per megawatt for a 1 megawatt wind farm of 50 wind turbines. The annual cost maybe of the wind farm maybe $70,000, $90,000, $130,000, $150,000. There's a lot of variable. Okay, it's not a fixed cost.
Right.
You may need a longer mast. You may need, it could be different. It may be difficult to reach, or it's very easy to reach. Depending on the model you choose and on the wind profile, you can produce 2 gigawatt hour of electricity per year, 2,000 megawatt hour, or 3 or 4. So if you have the same cost, say $70,000 per year for a wind farm of 1 megawatt, but you have small quantity of wind, it costs you $35 per megawatt hour. If you have the double energy, it costs you 17 cents. So it's exactly the same wind farm. Same cost. Everything is the same. You have more wind, the electricity cheaper. In average, we're going to work between 2.5 cents, okay, $25 per megawatt hour is 25 cents, 2.5 cents per kilowatt, to 5 cents per kilowatt. Most of the project going to be like that. But the most important is not necessarily what it costs. What is the benefit? What is the profit you can do with it? Okay, if you go up north in Northern Village, the cost for a 1 megawatt wind farm of 50 wind turbine might be $250,000, $300,000. So, but they have a lot of wind. So at the end, the cost of electricity might be $43 per megawatt or $50 per megawatt. But their cost just for the diesel is $250 to $500 per megawatt. So even if the cost is much higher there, their cost for the actual energy is so high that they're going to pay back their system in 2-3 years. Mm-hmm. So it's not only the cost of electricity, but what is the concept? Where is the place?
Yeah.
So if you sell electricity to the grid and you had wind turbine, you increase your cost. Okay, let's say you instead of $90,000, you add 20% wind turbine and you're 110, but you produce more electricity. So instead of cost you $30 per megawatt hour, cost you $31 per megawatt hour, but you sell 20% more electricity to the grid. That's profitable. So that's the main point, where it's not only a question of what it costs, but what you're going to do with it.
Yeah.
What's your need? What benefit you can get of it?
Yeah. Scaling climate hardware is a different game than scaling software. What is your manufacturing scale strategy, capacity planning, supplier strategy, quality systems, and repeatable assembly?
Very pleasant work for an industrial engineer again. Now, it's not, how can I say that? We're going to have to start with a small factory with small capacity. And it is correct, because our go-to-the-market strategy is not to try to sell, to go to the farmer and say, okay, you're going to make a $2 million project, you're going to put 50 wind turbine on your field. They are very conservative people. It's never going to work. And it's understanding. If I was at a place, I do the same. So we're going to say, okay, we're going to make you 2-3 wind turbine. You're going to test this for 1 year. You're going to produce electricity for your own purpose. You're going to see that the noise, the efficiency, and everything. From there, we're going to get order for a larger system after a year and a half. And then with this order, we're going to be able to finance a larger factory and to produce, make the vertical integration that we talked at the beginning.
Yeah.
But it's going to be step by step. And the fact that we're going to go step by step, it's going to be more efficient, because when we're going to make an investment, we're going to know exactly what's the best thing to do at this moment to reduce our costs or to improve our product.
Yeah. And where do you see the strongest early market fit, like industrial sites, municipalities, or remote infrastructure, commercial customers, utilities? And why is that segment best positioned to adopt mid-scale networks first?
We have a very versatile project, and a startup must be versatile, must be agile. We have core potential market. Off-grid village, not turn off-grid village, but every off-grid village that depend on diesel is very important market for us, because they can spare a lot of money with us. Farmer is also an important market for us, because they can sell electricity to the grid, and if half of the farmer in the US install 1 megawatt wind turbine in their field, they're going to produce half the electricity need of the US. Now, the potential is tremendous there also. It also could be corporation or municipality that's going to reduce their carbon footprint, that can use our product at several sites. We offer wind turbine. For us, it's the same thing. All this is the same thing. But there is a market we're going to have a faster response. We're a startup, we're going to go there.
Right.
If the northern community understand that they can make a lot of saving with us, eventually a lot of benefit, they're going to jump on our project and they're going to overload us. We won't try to go anywhere else.
That makes sense.
But they are conservative people. Maybe it's going to be the farmer, but they're also conservative people. The same thing, farmer. When we're going to have 2, 3, 4 farmers that make a good success of a wind turbine, they're going to come 100 at a time to have our project. If we have no demonstration, maybe it's going to be the corporation and municipality, because those people are more flexible for the kind of new changement, new stuff. Might be there that we're going to go at the end. So I cannot say I prefer this or I prefer that. I sell wind turbine. That's my point.
Right. Yet to be determined.
When I'm going to go up north, for example, and I'm going to make project for the northern village, my salesman's going to sell either, he's going to be distributor there anyway, but they're going to sell wind turbine, but they're going to sell batteries. They're going to sell an energy management system. They're going to sell each storage system. We supply the wind turbine and the business model.
Yeah.
Tell them how to work it. Well, maybe we're going to install also the same people, but it's going to be distributor up north. So they can come and buy a wind turbine, buy batteries, and put it there and, give the best service.
Yeah.
We don't try to make everything. We want to focus on the wind turbine and make them unbeatable. If we don't want to be overcome by Chinese product, for example, we have to think like vertical integration. Don't try to sell the wind turbine to make a big benefit with it. We're going to make reasonable steel factory benefit. And if they want to beat us, they're going to have to work hard. That's the way I think.
Yeah. Now, you reference carbon revenue potential tied to emissions reduction. How do you think about monetization beyond electricity, credits, incentives, compliance programs, and how material is that to your business case?
Okay. From the very beginning, my intention was to put on the market a project that don't need subsidies, because subsidies is dependent of politics. Very well that in the US now, it can change very fast. So you cannot build a business model on that. What I offer basically without subsidies. After, if there are subsidies, welcome. But we don't depend on that. Let's make an example. Let's make a quick example. If we get appropriate carbon tax for a wind turbine installed up north that we replace diesel, it's clear every megawatt hour we produce, it's megawatt not produced by diesel system. If we have $100 per ton of CO2 emission cancel after the expense, because it's expensive to have you have to hire specialists and everything. Let's say you have $75 in your pocket. Diesel is 900 kilowatt per megawatt hour. So if you have a wind farm of 1 megawatt up north, that produces 3 gigawatt hour, 3,000 megawatt hour. Theoretically, the credit should be $200,000 per year. The carbon tax return should be $200,000. for a wind farm that costs you less than $200,000. Theoretically, it's going to be free electricity.
Mm-hmm.
Access, I don't see that anywhere for the moment. Why? Well, politicians, they take the money, they charge the tax. It's not clear what they do with it. So if a fair trade market, exchange market, we should have a lot of people that produce electricity free with the carbon tax. For the moment, it's not happened. Maybe one day politicians going to understand we are running to a big problems. Maybe it's going to come. And at that point, it would be beneficial. Same thing for solar system and large wind turbine, for example. It is not only for our product.
Right.
But, step by step, there is some subsidies. Yeah. One day they are there, the day after they are not. And
it just changes a lot. Yeah, it's not.
It's too dependent on politics.
Uh-huh.
It's good if they can ace that, but it's not necessary for our project. It's not necessary.
Yeah. So, Frank, looking ahead, you mentioned the structural parts are currently metal and recyclable, with plans to assess carbon footprints against fiberglass structures. What improvements are next on your roadmap?
Improvement, we have first to put product on the market, and from there, we're going to be able to improve rapidly what is physical. The next step, maybe in 2 years, we're going to be able to manage the wind turbine differently, installing the sensor all around the wind farm, let's say 10 sensor, and have a kind of learning machine. I've not say I say learning machine because it's all on a small computer. And instead of react to the wind, we're going to say, okay, this wind turbine on the next 5 minutes, this is what you're going to receive. You're going to go at that speed. The other one beside is different. The other one, there's an obstacle in between. This could be an improvement, but it's going to be an improvement of 2-3%. Of course, it's free electricity at the end because it's the same wind farm. But
so finding ways to really optimize, the system and
regarding the recycling of the project, the wind turbine, our wind turbine is done. It's still galvanized steel 99%. Mm-hmm. So it's 99% recyclable, but it's built to last 50 years. So when it's going to be time to decommissioning, might not even be needed in 50 years. We won't be there anymore. So we'll see. But it's not a point because everything can be recycled.
Yeah.
So if needed, it could be recycled.
Yeah. Well, thank you so much, Frank, for joining me and sharing about how Windu is rethinking wind energy and making it more deployable, more acceptable to communities, and potentially more cost-effective through mid-scale turbine networks and manufacturing, driving innovation. So for listeners who want to learn more, where should they go to follow your work and learn more about Windu Energy?
Well, you can go on our website, wind-do.com. But you're going to have more interesting information maybe on our YouTube channel, Windu Preview. Because there, if you want to have information, for example, about computer simulation, you're going to see how a wind turbine work. You're going to see how we calculate the efficiency of a wind turbine. So there is, for the one who really want to go further, a YouTube channel is very good. It's a very good place to go.
Okay, so YouTube to see it in action.
They could also join me on LinkedIn because I talk a lot there.
Excellent. All right. Well, thank you, Frank.
Thank you for your invitation.
And to our listeners, if you enjoyed this conversation, please subscribe to Industry Ignited and share this episode with a colleague. And tune in for next time as we discuss more innovation and other things happening in the world of industry and manufacturing. Until next time, stay bold, stay curious, and keep igniting industry.